So in this video I'm going to give you a quick, well, it's actually probably going to be a fairly long multi-part video set that will cover the basics of Fulcro RAD. I've been working on this for some months, and it's still in development. It's still labeled alpha, but I really do think it's the right place to start on pretty much any Fulcro project at this point. It just does so many useful things for you that even though it's in alpha state, the pieces that are likely to change and evolve aren't likely to hurt you in a substantive way. The things that are evolving from an alpha perspective are things like the UI generation. And I don't expect anyone to necessarily deploy a production app with just generated UI. And you'll see through the tutorial series how the generated UI is useful for standing things up, and then once you get going, you can just like start using it, using other things to do it, or write your own plugins or whatever. But some of the starting pieces just give you some really nice things, and quite a few of those are quite stable. I'm not planning on any major external API changes, so in that sense I'll probably move it to beta or even a release candidate soon, and maybe leave the RAD UI plugins marked alpha, something like that. So I've made this repository for this video series, and just made it. This is essentially the Fulcro RAD demo pared down, so it's a little simpler to look at. It only supports Datomic free. I'm not trying to show you how to use various database adapters, etc. I'm going to show you the general structure, how things work, how you can escape from the things that you don't want, how you can augment the things that don't do what you want, etc. It's really meant to be a system that lets you, do base Fulcro development and go in any direction you want to go with just some nice pieces already in place for rapid application development. So I've already cloned this repository, so I'm going to import it. It's in my Fulcro logic. I thought I just stuck it in here. Sorry, I was just moving things around. Oh, maybe I didn't move it. There we go. That's where I wanted it. Okay, and I'm just going to use IntelliJ here. Feel free to follow along in whatever system you want. There are instructions in the README on how to start this up from the command line, but I prefer to have IDE. Now, this project comes with quite a bit of stuff, and if you're following along in the README or here, the first thing we do is we run yarn to pull in the npm deps, which I had already done on this project, and then we can run a shadow CLJS watch on the main build. And if we look at the shadow CLJS Eden file, I've only got one build in here. There's a little bit of extra setup if you want some of RAD's additional features, like RAD supports datetime functions that it can be time zone aware, and so this is a way of pulling in a smaller time zone definition file so that time zones work isomorphically across closure and closure script, that sort of thing. So once you've got those in there, you can say shadow CLJS watch main. That'll start with the compiler, and it'll start compiling. If you want to see compile errors and stuff, then you need to go to localhost 9630 here, and just look at the dashboard's good enough. Once it starts, it'll give that URL. And then it'll start giving you updates on what it's doing. Now I'm using guardrails here, which is a project I forked off of Ghostwheel that just does some type checking on functions as they get called, but using specs. So it's sort of like runtime instrumentation without exceptions being thrown. It just logs messages to tell you where something didn't match what was expected, which helps you debug problems. Okay, so that's running. I don't really need to look at it anymore now. I could just use, start the Clojure server down here, but I'm going to go up to my Clojure deps tab, and I'm going to set my alias, my dev alias. And if you look in the deps Eden file here, the deps Eden file has a dev alias that adds source dev, and source dev has my development namespace for starting things up and seeding some test data, that sort of thing. So I'm gonna throw that in, make sure that that's loaded. I'm gonna add a local. Here, let me just do that so you see what that looks like. I'm gonna add a local Clojure REPL. I'm going to tell it in REPL, run with IntelliJ class path, which will use this Clojure deps tab results, so I can modify that as I go. And then I've got some keyboard shortcuts set up that require me to set this flag for them to work right. So you could ignore that bit. The project itself doesn't care about that. This is something my IDE cares about. So the way I've got it set up. I'm going to label that CLJ and apply that. And then while I'm here, I'm going to go ahead and add a remote CLJS, which is an in REPL localhost, and then I believe I've got Shadow running on port 9000. We'll double check that, but pretty sure. So if I go look at Shadow, oh, yeah, in REPL server on port 9000. So once I bring the app up in a browser, I can talk to the browser with that guy. Okay, so I'm going to start my Clojure REPL here, get rid of this deps tab, and this refresh DIRS doesn't need to have all this mess on it anymore. Let's see, that's source main, source dev. Don't need the development sources there. That'll make more sense. And then I'm going to hit my keyboard shortcut, which is going to essentially go to the development namespace, require it, put me in there, and this is why I had to set that thing. I have my IDE set up so that it won't try to start a server if I'm in, say, a test REPL, which could screw up all my tests. So I have it double checked to make sure I've set the dev flag so that I don't accidentally run that command in a test REPL. So this is running, and this puts the web server on port 3000 is the way I've got it configured, and we'll talk about the bits of this as I go. Oops, wrong key. So I'm going to pop over to Chrome. I'm going to open a new tab and localhost 3000, and I'm going to open up my dev tools just to make sure that caching doesn't bite me. I'm going to log in, and you can see I'm working. I can see some tools I can play with here. I can view some accounts. I can sort some things, etc. Okay, so let's talk about what all's here. So this first video is basically going to be just a grand tour of what's in the project, and then we'll do some further videos on mucking with things. So let's talk first about the backend. So the backend has several pieces, and most of these are covered in the RAD book, which I've got a link to in the Slack channel. But this is still under development. It's 50 or so pages. It covers a decent amount of the setup and the stuff I'm going to be talking about here. So I'm going to let you lean on that as well. But it's just nice to see it. So I'm using mount, so I have def states and then the name of the thing that the thing's going to end up in, and this is just an immutant server running middleware. Okay, so normal Ring middleware server, nothing fancy there. If I go to the Ring middleware, this has this wrap HTML routes. This is an HTML5 app, so notice the URL has all this mess in it. Notice I've got them sorted by account name, and let's go the opposite order. Right? Let's put Barbara first. Let's show inactive accounts and disable one, and then let's reload that. And I should see Barbara first, and Sally's disabled. And right, I can completely close that tab, open a new one up, and still sorted that way. I can highlight a row, reload the page. The highlighting's even kept. So in order for this to work, any URL that I pass in that isn't recognized as like an API URL or something needs to serve just this HTML page. So the Ring middleware, this HTML routes, looks for /API, which is where my EQL network API goes. Images is where I serve image files out of. Files is where I upload files to. And JS, of course, is where the JS source code is. So if it starts with any of those, then I let the rest of the Ring handler handle it. Otherwise, it's the index page. I do have CSRF installed. And so if you go look at I'm using Hiccup here to generate the page. This is just sort of a standard little thing. We throw the CSRF token in a var in the global space of JavaScript, and then the networking remote on the client side picks that up and adds it to a header so that we can tell we're talking to something that we initialized through HTML. The automatic rendering I'm using, the rendering plugin, is using Semantic UI, so I'm pulling in semantics. Actually, the Fumantic project adopted the Semantic UI and is maintaining it. The original maintainer stopped maintaining it. So I'm pulling in that style sheet and serving the JS, and I've got a div app. So very standard Ring middleware fare. And these bits have to do with making sure Fulcro's Eden inputs and outputs are encoded properly. These two are a RAD plugin that allows you to do file upload and file serving. So that's what those are for. This is a file upload plugin from, I believe that's coded in Fulcro itself. Yeah. And what this does is it allows mutations to send, well, basically you sort of do this parallel thing where you post the file upload and a temp ID gets kind of associated with it. And then when you actually send the mutation refers to it, and then in the mutation body you'll see a Java IO file object for that parameter. So it'll kind of join them back up. So that's the middleware that kind of merges the two back together on a file upload. And then every other part of the API is handled by this wrap API, which is a standard Fulcro setup. Right? This is the standard handle API request, and you give it a function that can take a query and return a response. And here we're using a Pathom parser, and we're adding into the parser env the current Ring request, and then sending the query. And then of course this will give us our response. So wrap API is looking at /API, and so when the URI is /API, that handles it. Otherwise it continues up the chain to, in this case, not found. Now config is handled by Fulcro's config namespace, and this is a really simple namespace. What it does is it allows you to, let's go over to the config component. This load config function, you tell it a config path, and this is the config file you want it to load. It always looks for a default file. So if I go look in the config directory here, there's a default Eden, and this has all my default settings. Notice it's just a nested map. Dev, you could put anything in this map that appeared in this map or more, and it does a deep merge of the two. And then prod has the same thing. So basically this config, I can pass it through mount. This config component, I can pass it a config property so that a production main could say I want to use prod Eden, but in development mode I can say dev Eden. So then I can get different settings for different environments. And these Eden files support some additional things. You can look at the Fulcro docs. There's support for things like environment variables and such. Okay, so let's pop back to the middleware. I think is where we're at. So other than adding in this file handling stuff, this is stock Fulcro. There's really nothing here at all that's non-standard. This is just Ring defaults, like that's Ring middleware defaults. This is this function right here. These two are standard Fulcro server transit encoding stuff. These three, well, this one has to do with specifically dealing with file upload network integration, and these two are an add-on from RAD for binary large object generalization. They give you some additional helpers that the automatic UI can just deal with. Okay, so the real workhorse in RAD is the Pathom parser. So this really is a standard, and in this case, RAD comes with a wrapper. Here, so if we go in and look at new parser, you see that's from RAD. This has some preset plugins that it always includes for doing things like eliding not founds, getting rid of reader errors, putting the query params from the queries from Fulcro into the environment, optionally adding in a trace plugin, etc. So you could build this all by hand, but the new parser function from RAD gives you some presets, and then you just add additional plugins in, and then a list of resolvers you want. And so I'm going to let you use the Pathom documentation to kind of understand that fully. But let me talk through what we have here in terms of kind of the Pathom plugins that you typically use with RAD and what they do for you. This is plugins are just maps. So each one of these functions returns a map. And so this kind of plugin says wrap the entire parse. And all I'm doing here is I'm using RAD's datetime with time zone to give a time zone name to say I want all of the parsing to run in the context of this time zone. So if I wanted to support user locales, as the user came in, I'd look at the request and say, oh, it's that user, look at their settings and say, oh, they're in this time zone, and I could put it here, and now all of my resolvers will do the right thing if I use the RAD datetime library or datetime namespace. Welcome to send me contributions for this datetime namespace. I'm slowly kind of adding things to it as I get to them. Mainly what's in there right now are things for supporting inputs, data inputs. So when I go to something like this inventory and say new invoice, and I've got a date here, I want that to be a locale aware date. I don't want it to be a date that says 8/5 for me, just because the server happens to be in Pacific time zone, but it says 8/6 for somebody else who's in a different time. I just want it to be right. So these controls use the time zone aware datetime namespace from RAD to make sure these are all insts. So you always have a if it's a starting date, it's always midnight of this date. If it's an ending date, it's actually midnight of the next day, and the control can be told it's an ending date, and it'll automatically show the right date. So you have open-ended ranges, which is kind of a standard way of doing, like if you're doing a report, and you've got a start and an ending date. This is actually 1/1/2021 at midnight in the Fulcro database. So just kind of a commentary there. So there's time zone support. So that's what that's adding in. This is the Pathom plugin from the blob namespace that can handle dealing with file uploads, basically. And so you can look at the documentation on that. This is a Pathom plugin for the Datomic RAD plugin for doing reads and writes to and from a Datomic database. And that can be configured, and it takes a function for selecting the connection from the env, basically. So I'm cheating here and actually just using the one and only connection that I know is here. There's a form plugin for doing saves and deletes on entities. So this is a layer kind of above Datomic. We'll see in a minute when we look at these two pieces of middleware that there's some Datomic stuff that gets mixed in here as well. And then this attribute plugin just makes the overall parser aware of the attributes that are defined in the RAD model. So RAD basically has you define everything as attributes, keys that go with a particular fact in your data model. So so that's basically how you set up the Pathom parser, and then of course each one of these pieces has different pieces. I'm not really going to cover the blob stuff very much. The Pathom plugin is trivial. Basically, you just have to give it a function that returns a connection, and it gets the Pathom env, so you can dig stuff out of that. The form plugin is required. You have to set up the save and delete middleware. I'll show you that in just a second. And then this, all attributes, is literally just a concatenation of all of the attributes in the entire system, where the attributes is just a vector of, these are just manually created vectors of attributes. So literally that's just like a list of them all. And then resolvers. So the way Pathom works is it uses resolvers to figure out how to get the data for queries and how to run the mutations for mutations. So each one of these are handwritten resolvers. So I could take you to account resolvers and you'd see that's just a vector of like handwritten mutations that I wrote for some purpose. So in this particular demo, I use the resolvers names for things I've handwritten, time zone resolvers, sales resolvers, right? This is like for reporting. There's some like handwritten, queries and such. In that case, I'm just randomly generating some data just to make a fake report. The blob resolvers, this is the join point between being able to define an attribute that can refer to a saved file and the blob hookup that does the actual saving. The form resolvers, we'll get to that in a minute, and then the automatic resolvers. So let's see which piece first. Let's do the middleware for the form first. This is kind of mostly boilerplate. Some of this stuff might move into the library proper where you just don't have to enter it at all. But the save middleware, this is middleware that gets run when RAD sees a form save. So one of the really cool things about RAD is that a save is one function. Saves are normalized attribute data that a database adapter can figure out from one mutation. There's no reason to have a bunch of mutations. So for example, the datomic save, if I pop over here, it has a save form function, and it's this code, txn, this delta to transaction, which builds up a to1 and a to many transaction. So this namespace from about, from about here, 176, through about here, line 300, is all it takes to save a form in Datomic. Any kind of to many, to one, scalar attributes, etc., that does it all. And it's similarly tractable for other databases. So when you do a form save, I'm using some extra handwritten middleware here that lets me rewrite what the delta looks like. I'm adding in the blob middleware that'll associate the proper things with attributes from the persisted images, and then doing the Datomic save, which will handle any attributes that say they go in Datomic. So it's really a pretty simple kind of boilerplatey thing to set up, although I guess it's not complete boilerplate. You have to say which pieces you're plugging in. And these are like, this is that entire plugin. So please look at the source. It's really not hard stuff. In this particular case, this is a multi-method rewrite value where you can dispatch based on the ident of an incoming entity and rewrite what the diff says. So let's say you've got some field and it always gets written as an int from the client, but you always want it to be a big int in the database. Right here you could make your own multi-method that could watch for those and fix them, that sort of thing. That's what this middleware is for. And so it's really easy for you to add in your own. So that's save middleware. Go Go back a bit. And then there's delete middleware, which typically you just have your database delete wrapper on that. Now this is also where you could mix in security concerns, right? You could, in this middleware, you're going to receive the parsing end, which has the request, and so you could add a layer to this that could check the incoming request against the session to see if they have permission to do the things. And so same thing with the save middleware, right? That this could have additional layers to this that do the security portion. And your attributes could actually cross various databases, right? You could have an SQL wrap SQL save, and a Redis wrap Redis save, and a Firebase and whatever, Mongo, and hard disk file, whatever. Each one of these will get the complete diff of what needs to be saved, and they can pick off the attributes that go in their database. So you can do a multi-store story very easily. So that's why it's a middleware sort of structure, is to make it kind of arbitrarily pluggable. Okay, and then resolvers. You can handwrite all of the resolvers. There's nothing in RAD that requires you use generated resolvers. If you happen to have a database plugin, and the Datomic one happens to be one that understands how to generate some resolvers, then you can certainly plug those in. If I go look at automated resolvers, you see this is a def state that calls this base resolvers namespace generate resolvers. This just looks at attributes that explicitly declare Pathom resolvers. I'm trying to think of one that I've got in this project. Yeah, this would be an example of one, but let's see if I can find a better example. Here's one. So this is an attribute that is called item all items, that is a ref attribute, defaults to 1. So this is a the to one too many is advisory to the database adapter, and since we're not using a database adapter, we don't have to say it. We could, right? That would look like that. And so here we can actually declare the things that we'd put on a Pathom resolver, PC output, PC resolve, and all this function does back here in the auto resolvers. This function here just goes looking for those. It looks through all the attributes, finds the ones that explicitly declare a PC resolve, and pulls them out as resolvers. And then this guy looks through all attributes for those that are declared to be on this schema and generates resolvers for them. And so if you had multiple databases with multiple schemas, right, you could generate resolvers for each one. And if you had an SQL database where you wanted some resolvers generated from the same, right, the attributes are the core thing. So again, this is how you could have automatically generated resolvers. And I'll talk about here in a little bit how Datomic figures out how to generate resolvers. It's actually really easy for any database to generate these resolvers, because resolvers are just maps. In fact, I could just show you real quick. If I go to my REPL here, I'm going to go into this namespace, I'm going to load it, and then I'm going to just evaluate this one expression right here, the generate resolvers. And notice this is just a bunch of maps. Right, we'll just look at the last one that pops out here. So this map is a file ID resolver. It outputs file ID, file SHA file name, and file uploaded on. It can be batched, and it has a function that is the resolver, and its input has to be file ID. Now if you think about, if you know Datomic, you know that if you have an ID of an entity, that there's the pull query for the attributes. So really, if you look at the generated function, all this is a dpull. Essentially, it's a dpull mini, actually, because of the batching, with this query and whatever file ID or IDs came in. So you can see for Datomic, it's really simple to do one layer. And if it's something that's got a join in it, like right here where line item resolver has an input of line item ID, again, that's a Datomic pull query that results in me having an item ID. And then if I've asked for more stuff, Pathom can automatically go looking for a resolver that can take me down this leg. So again, these are all just really simple generated pull queries, and you could do the same thing for SQL, where they're all just they need to be no more than that deep, because once you get to the next ID, you can go to the next resolver and resolve it. So it sounds like all fancy, complicated stuff, but in fact, the ID resolver for Datomic is literally that much code. Right, here's do an entity query, where an entity query is nothing more than a bit of data munging followed by a get by IDs, which is a pull star. So don't be intimidated. Again, look at the source if you don't understand something, but hopefully you're seeing very quickly that there's nothing in RAD that puts you into any sort of corner. Right? It's all Pathom resolvers. If you happen to want to use the generated ones, great, they work for you. If you don't want to use generated ones, don't use them. Use your own database, hand code these things, what have you. I think you'll find that once you've put the data in the attributes to describe what things are, it's really easy to write code that just generates that crap. So why not do it? Why not use it? Okay, so let's go back a little bit. Jumping around through a lot of pieces here, a lot of back buttons to find where I was. Okay, so those are the automatic resolvers. Form resolvers, this basically just adds save form and delete entity. These are just two predefined mutations. And notice what they do is they use the middleware. So the middleware ends up in the Pathom env, and then these predefined save and delete mutations in this namespace allow me to write automatic code on the front end that knows when I'm trying to save something, we'll call save form, and then it'll use the middleware to figure out how to actually put the stuff in the database. So this is again pretty thin, right? This file is kind of long, but this namespace form is a CLJC file that handles saving, deleting, and pretty much all of the UI except for actual UI generation. So for example, if we go up here and take a look, form controls are in here. The outline for rendering, notice there's no DOM stuff in here, but how the rendering is structured goes in here. Form nesting, generating new instances of forms, default values, the form state machine, what to do on routing, form will enter, form will leave, like doing things like denying route changes because the form's dirty, right? So a whole bunch of logic that you would normally have to write is in this namespace, which is why it's so big. But in terms of the server side of it, is basically the middleware that you add in. There's save, right? Save calls save form star pulls out the middleware and calls your middleware. That's save. And delete similar. So that's what's in the Pathom parser. There's a lot here in terms of functionality, but again, I encourage you not to be intimidated by the fact that it seems to do a lot for you. Each one of these pieces is relatively straightforward if you understand its core concepts, and most of those concepts are Pathom resolvers and middleware. So the middleware concept, if you're new to Clojure in general, study up on that, threading these functions through each other is a little heady when you first look at it. Okay, so there's our ring middleware. Most of our work is done by the parser. Most of the parser's work is done by resolvers. Many of the resolvers can just be generated for you. That's kind of the base level. I'm not going to cover the blob store really. I've already talked about the auto resolvers, just like literally it looks through all attributes and finds the ones that have PC resolve in them. Config is Fulcro's config. This database queries namespace is just some functions that can run datomic queries for me. In the original demo, there's an SQL version of this and a datomic version of this to pull that into separate source directories, but I just pulled it in here. So like get all categories just does a query on the database looking for things that have a category label and pulls out the category ID and maps that over and gives back a map of those. Not really much to it. Notice the end here you end up with the datomic databases in here, so you can pull the database out, etc. So, and this is an atom, and that's important because if you do a mutation that has follow-on reads, or it's a mutation join is what it's called. It does a mutation and then a follow query. Usually you're querying for the thing you just mutated. You want to query out of that updated database. So mutations are automatically update an atom in the env that holds the database so that you get the most recent database since the last transaction. I've shown you the delete and save middleware. That's the server. That really is the server. The database queries is the majority of the handwritten code on this server. The rest of this is gluing together existing RAD pieces or Fulcro pieces. So, glancing through it again, all resolver is tiny. Blob store, just setting up. In this case, this is a little helper that creates a blob store just in your temp directory, whatever that happens to be, just for playing, so that you can actually upload files to your local disk but not have to worry about cruft. Config is just that Fulcro config. Database queries these handwritten few queries. The datomic bit is just starting the database. The delete middleware is literally one line. The parser itself is the real workhorse, but it's pretty tight too, right? Give me all the resolvers you want and what plugins you want to use. Ring middleware, very stock stuff. Save middleware, again, this is form middleware, so this is just figuring out how to take an incoming save and, in this case, rewrite the diff, persist in the images that go with the attributes in the database, or actually it associates attributes with the images that are available and then put them in a database. Middleware runs from bottom up for those of you who are new to it. And then the server itself, literally just a mutant web run on the middleware. That's the server. There is a logging namespace that's CLJC that I've put in here just to add in some helpers that configure the logging to make it a little tighter. So if you notice in my log messages over here, restart the server, I just have a one letter for level, D for debug, I for info, a more compressed time, and then my log message is a little easier to read in development as a result of this. So I clip the namespace so that all my messages end up aligned in the same column. So nothing crazy special there. Okay, so that's the overview of the server. It's going to be a bit longer as we walk through this. So let's take a look at what we have here. So attributes. The basic setup here is the recommended way to do this is you create a model file and you create an all attributes def and an all attribute validator. And in all attributes, you basically require all of your model namespaces that have attributes, and inside of each of those, you def an attributes vector that you list all of your attributes in, and then you just put them all together here. So this is one of the requirements of RAD is you have to hand it all of the attributes in your data model for it to understand how to do anything. And instead of having things that side effect, which they're convenient, but they're also real debugging nightmares. So because this gives you a very explicit traceability path, if something isn't showing up in your model, it's because it's not listed in an attribute, and it's not because you accidentally cleaned up a require or something and a side effect didn't happen. So I put all of my attributes in a vector, all of my handwritten resolvers in a vector, and then attributes I combine here. This is a function that can make a generic validator based on attribute settings for using in the UI. And so you passed all the attributes and it looks through them and figures out validation rules for them based on what you've declared in the attributes. Okay, so let's get to the model. The model's pretty straightforward. All of this stuff is meant to be pretty tractable. So, the namespaces that end in hyphen options, with the exception of picker options, which is a little bit, it's a name I picked before I went to this standard, so picker options is a little odd. But attribute options, form options, these namespaces define keys for you. So the trick here is you can say ::attr/identity true and just use the attr namespace to name a particular option that this attribute needs. And that's this namespace. Unfortunately, this means that if you make a typo, you have no idea you screwed it up. And it also means you've got no doc strings. So instead of doing that mess, what I did instead was I created these namespaces, and they have nothing more in them but defs of a var that are the symbol, not the symbol, the keyword you want to use along with a doc string. So you can get a doc string. That's really what those are for, and you can get completion, right? You can look through and go, oh yeah, what do I need? Oh right, I need cardinality 1 for that. And what does it take? It can be 1 or many, right? So that makes it a little easier to discover things. Good idea to just read the entire, just read this entire namespace, just understand what's available. Same thing with any of these options. Now, RAD is built around the idea that entities will have an ID that has a unique name that goes with that entity. So that's concept number 1. You can use native IDs. I don't personally do that, so I've not spent a lot of time debugging those and making those work well. So for example, if you wanted to use DBID, I think you can say datomic native true, something like that if you're using datomic, and that tells the driver underneath to map these names to DBID. But I'm going to recommend, just for the sake of playing and understanding how the datomic adapter works, give yourself something like a UUID for account ID. This marks it as something that identifies entities, and any entity in the database has to have at least one identifying attribute. This defines what schema you expect it to go with. Now you could use the same schema across different kinds of databases even. This is just a made-up name that you use to configure in the other plugins. So when I configure my datomic plugin, I tell it I'm going to have a production schema, and when I ask it to do things like generate, oh, I didn't see the generator. There's actually a generator, which is probably in my server startup, where I can generate, auto-generate the schema using the plugin. And I'm not using the SQL guy, so let's just strip those out so we don't confuse ourselves. Yeah, so just pretend like those aren't there if you see them in the source. So that's kind of the minimum amount of things that you'd put in something that's going to go in a real database. If this was something you were going to write a resolver for yourself, you wouldn't even need that. Okay, so you go through and you define your attributes. You give them a symbolic name, a keyword that becomes its kind of RDF style namespaced name in the data model. Its data type, and these data types are extensible. You can really use anything here, and it really boils down to, does your rendering understand it, and does your database adapter understand it? So you kind of have to look at the documentation for those two things to find out what data types to use there. There are also things like style, which again is it's just kind of a made up thing. This can be a keyword or a function that returns a keyword that indicates, okay, this is a string, but maybe it's a social security number, or maybe it's a phone number that I want to have hyphens in it, that sort of thing. So style is a hint to the rendering and validation layers if your plugin supports it. So this is kind of a fully extensible look at the documentation to find out what you can put here, to kind of say what style this thing is. What is this really, and more specific. Required is a hint, again, to the various plugin layers of whether or not this thing is required to be on whatever entities it lives on. And this one is the join point. So identities names all of the identity true attributes in your data model on which this fact, account email, can live. So in cases where you've got something like, why is that giving me an error? Oh, I accidentally deleted my opening curly brace. Let's say you've got something that you put on multiple different entities, like a reference number, right? That might go on, orders. It might also go on images. It might also go on whatever, right? So that's the idea. Is the this defines. Oops, one more. This defines which entities this fact is expected to live on. This is used by resolver generators. So when Datomic comes along and it says, I'm working on production schema, oh, this is a production attribute, so this must go in my database. I want to write a resolver for that. How do I get to account emails? Oh, I get to account emails because I'll be given an account ID. So given an account ID, I can give you an account email. That's exactly how a resolver is generated for this. So it scans through, it says, I'm a database provider for production schema. This says an account ID might have an account email, so if somebody gives me an account ID, I can give an account email, and the way I'd look it up is do a query for an entity with account ID, blah, and give me account email, right? You can see in SQL be the same thing, right? Select account.email from account where account.id equals whatever incoming account ID. Like, it's trivial to generate a resolver for this attribute. And it's trivial to generate more than one resolver, right? That now generates two resolvers if I'm using automatic resolvers in a database plugin, one that can start from other ID, one that can start from account ID. If you want additional resolution, so say for example, I decide I want account email to be resolvable from something else, you could define your own custom Pathom resolver and say PC input is account, so you make these unique, and this could PC output an account ID. And now you've got a way to start a query, and then of course the resolver, the code to actually do this query, select where email equals blah, select ID where email equals blah, is the resolver body. This would let you go from account email on a query to an account and get all the details from there. Okay. And then the various adapters, right? These are open maps. You have some custom plugin thing, you just stick it in this map. And then if you want to go find that attribute, it's in a lookup map in the environment of Pathom. So every resolver would have all of these facts about each attribute. Now these are also CLJC. So if you do write some attribute in here, let's say that this is a function that expects imp, and this is going to be some closure specific code, then make sure that you wrap it in a reader conditional, so that that doesn't break your front end compiles. So these become a universal source of truth on both the front end and back end about individual attributes. Okay, so that's enough of an initial tour of those basics. I know we're getting kind of long on this video. Let's see what this actually looks like once we start combining the pieces. So you've seen all of the back end. You've seen what attributes look like. Let's go look at what a UI looks like. So our main UI here just has basically some drop-down menus. Right, so I can put that on top and this on bottom, and we can see this account menu has view all and new, view all and new. And note, I'm using some RAD routing where I can route straight to a UI component. And I've got a form helper that lets me go straight to a particular form. So when I say new account here, I'm going straight to, I'm going to jump in code, this form. And this form is keyed by form ID. So these are form options, right? The attribute that will act as the primary key for this form. And then I'm going to list out the attributes I want. Name, primary address, role, time zone, email, right? And notice primary address is a subform. This is a 2-1 relation just to show how 2-1s are done. So this entire form that I've got here, which includes file uploads, adding additional addresses, which is a too many, setting the email, using a drop down to find a particular time zone to set myself in a time zone, state drop down, etc. With undo that can clear all that stuff out, cancel, etc., which goes back. That's a whole lot of functionality for line 70 back through 36, 34 lines of code. Actually, there's a little more than that because there's an address form, a file form, and so we can see the address form here. There's another 7 lines of code, and there's a file form for the file upload. All right, there's another 8 lines of code. So this is the real crux of RAD, is very quickly being able to stand up some simple CRUD style stuff, some reports that show me some things, some editing with some validation to let me make new things. If I do new here and hit save, oops, and I hit a bug. Why did I hit a... Yeah, I hit some rendering bug in my rendering plugin. I had absolutely nothing filled out, which I usually don't do. Yep. All right. So there's a great demo. That must be something I broke here recently. The point is the validation is there as well, and I'm not sure why that particular one. There we go. Picker, line item, category, widget. If I lose the quantity, probably time zone related. I was messing with time zones over an account. So you can see I get validation, I get some calculated fields out of here, etc. You also see that this URL, as I'm moving around, the URL is constantly updating, keeping track of what particular thing I'm doing and where I'm at. So if I reload the oh shoot, I got the create instead of the edit. You all, I think it was that one. I should be able to reload and go back to that. Same, yeah. Same guy. So the combination of this HTML5 routing, the real quick use of these things, buys you a lot for standing up a system quickly. In the next video, I'll cover a little more about how you build these individual pieces and what some of the pieces mean and how you very quickly can escape from any of